Hello, everyone. This week is Singapore's National Day, 58 years of independence. So I would like to discuss these questions, which is from different sources. So first of all, this is quite an interesting question. You can see the egg, right? It's actually submerged. Okay, by the way, if you buy eggs, right, and if the egg floats on water, it's a rotten egg. So a good egg will sink. So you can see here in this experiment, if you want to find out how the amount of salt added to a beaker of tap water, so as we know that tap water does not have any salt content. So it's like fresh water. So take note, this is tap water, would affect the position of an egg in the water. So this one should add 0, means it is like a control setup. This one, 3 tablespoonful. The egg actually floated up slightly. And if you add 5, the egg actually floats fully. But in reality, I believe that you may need more, definitely more than 3, perhaps like 13. Like 13 tablespoons, and this one maybe perhaps 25 in reality. Because you need to make the solution very concentrated so that the density of the salt water exceeds the density of the egg, causing the egg to float. So for this question, they only ask you about a relationship question. What can Shirley conclude from the experiment above? So basically, you just need to mention this fact of observation that the more tablespoonful of salt added, the position of the egg floating in the beaker would be higher. Okay, something along that line. So I put it here for you to check your answers. Okay. Yeah. Okay. The more tablespoon of salt added, the position of the egg floating in the beaker will be higher, as long as you mention this relationship. Okay, next, this diagram is application questions. Okay, you know that the ocean is actually seawater, right? It has a lot of salt content inside. So if you observe the sides of a ship, right, they have this marking. So for this ship, they have ABC. And they say that this ship was currently at sea with salt water and is at position B. And if the ship moves to a place with fresh water instead, where will the water level be on the markings on the boat? So now it's entering from salt water, right? So it's from a higher density to a lower density. That means lower density in this example here, you see the less salt, right? Less salt, they will sink, right? So this one also less salt, so they will move downwards. They will sink deeper. So we will be at position A. Okay? So this one will be at A. At A. And the reason is, as a ship moves from salt water to fresh water, the ship will sink deeper into the water. Thus, the water level would be higher than the current level at B. So this is an interesting question of observation. I will screenshot this and send to the people in this group here. Okay, so I go to the chat and screenshot this portion for you to retain the answer. Okay, now there are 10% in the class. Very good. Okay, so these are application questions. Okay, moving on to the next question. Okay, I want you to draw a straight line from the torch shining through cardboard C, B, and A. Okay, so they say when the torch was shone on 3 opaque cardboards. So I want you to highlight this part. Okay, opaque cardboards means light cannot pass through. With holes of various shape in the middle, as shown, a shadow was formed on this screen. Okay. How can a shadow be made bigger by moving just the torchlight? So it's very simple. You just mention, move the torchlight nearer to cardboard C. Okay, this one. The torch can be moved nearer to cardboard C. Okay, now you're supposed to shade the shadow. So actually what you need to shade is, okay, if you observe here, right, as the ray of light goes through, so definitely it will go through this rectangular hole in cardboard C, and will go through this hole in cardboard B. Okay, however, the sides of cardboard B, right, the opaque portion would overshadow the heart shape. Okay, so actually what you see here will only be a circular light dot. Circular light dot. So in other words, if you shade the shadow, right, you should actually shade everything, right? Everything, retaining only the dots in the center. Okay, retaining only the dots. So you should shade everything, this part. Okay, within this box of everything, we change to a thinner control level. So your shading should be something like that. Even the heart shape will be covered. Only left with the circular hole in the center. Okay. So your answer should be something like this. Okay, something like this, the screen. Okay, next. Okay, this is the relationship questions. Okay, before that, let me screenshot this for those who need the answer. Yeah, I've seen some of your answers. Thank you for sharing on the chat box. Because you can draw it there, it's easier. I use the digital drawing. Yeah. So yours is okay. Yeah, in T1 can. Okay, so I'm sharing one of the students' answer there. This is my first time capturing a copied function. Okay, so this part. Okay, let's return back to the question. Okay, here. Okay, in this setup, you can see the support increases in height. So there's been this part is being elevated higher each time. And the time taken for the cube to slide down actually decreases because steeper, right? So this one, they ask you to state the relationship. Okay, so you mentioned very straightforward. This one is giveaway marks on. So in the exam, if such thing occur, you should be able to secure the full marks for such questions. Okay. So you mentioned about this, the time taken. Okay, I prefer you to use this word. The higher the height of the support, the faster the time taken, or the shorter. Because they ask you time taken, right? So I prefer you to use the word the shorter the time taken rather than faster. Faster is for time, for speed, sorry. So I prefer you to use this word. Okay. The higher the height of the support, the shorter the time taken for the cube to slide down. Okay, for time we use long and short. For speed we use fast and slow. Okay, yeah, because initially some student wrote the higher the height of the support, the faster the time taken. Yeah. So for time taken, to be more proper, we use either longer or shorter. So in this case, it's shorter. Okay, next question is also comparing two ramps. One is 20 centimeters, one is 25. And interestingly, both the cubes slide down in 5 seconds. So which ramp had a smoother surface? So if you analyze this, right, definitely ramp A has a smoother surface. And the reason is because the height of ramp A is lower than ramp B. Okay, so ramp A has a smoother surface. And the explanation is the height of the support is lower than RAM B, yet it took the same time, right, for the cube to reach the bottom. Okay, so this is the explanation. Okay, the height of the support is lower than RAM B, yet it took the same time for the cube to reach the bottom. Okay, next. Okay, since you know that RAM A is smoother, right, that means RAM B is rougher. So in order to prevent anyone from slipping, so is to choose a rougher material. So definitely you should choose RAM B because it's a rougher surface than RAM A. Thus, you provide more frictional force. So for the part B, so you indicate this, and the reason is okay. Thus, it provides more friction or greater frictional force between the floor and the feet to prevent slipping. Okay. So this question, maybe I capture separately so that you can see the questions. Okay, let me see some of your questions here. You must credit me. Can you say the smaller the time? Okay. The smaller the time. Don't say the smaller the time. It's not so good. The shorter the time, okay, to be more specific, to be more grammatically correct. So you say the shorter the time, not the smaller the time. The smaller is for size. Okay. And this part. Okay. Okay, this part capture and then send to the group. Okay, so this part you can see. So that day when I was teaching a class, when I pronounced the word slipping, because there's another word which sounded almost the same. So I was asking the student in my class, what happens if these two words occurs very closely in your English oral exam? How do you pronounce them? Sleeping, 睡觉, sleeping, like fall down. Sleeping is like faster, right? So perhaps I was asking them to read a short paragraph saying that something about a person, he was sleeping and he'd sleep. Some people have this, they call the what? Sleepwalking. Sleepwalking means like they actually got up and walked in sleep. So if you sleepwalk, you may slip if the floor does not have any frictional force, or if the frictional force is very low, or maybe you trip over something. Okay, so I've gone through this part, and now let's proceed with this very interesting poll vote, this event. Okay, so this question shares about, okay, after this question, I will pause for any questions to be asked. Okay, so actually I asked you for the main form of energy. So it's quite straightforward. At position A, because the man is running ahead, right, at high speed. Okay. So it will be kinetic energy. Okay. Position A, point A. Wait, let me copy this. So it's kinetic energy. And then point C, actually both. Because the person is actually above the ground as well. So you have the both types. Kinetic energy and gravitational potential. So I understand some of you just put the word potential is also acceptable, but to be more specific is gravitational potential. And similarly, the last one, the person is at his highest position. So that would be gravitational potential. at point D, this part, the highest point. So I will screenshot this section, and then we'll discuss here, this part. Capture, send. Okay, next. What form of energy does the pole? So I want to highlight this part because some students, they do not see this word here. Does the pole? Okay, does the pole possess? Not the person, the pole possess at point C, that's me at this position, that allow the man to propel forward, means move forward. Okay, so that's it from, you can annotate this part. That's mean what is the energy of the pole that helps the person to move to position D. So you can annotate this way. So we know that this pole vault, the modern days pole is made of fiberglass, which has a high elastic potential energy. So this part should be the elastic potential energy. So you write in full. I wrote in short form, but I want to write in full. It's the elastic potential energy. Of course, if you write potential energy for PSLE, you won't be penalized because MOE allows you all to use interchangeably the potential energy to cover 3 types. But to learn it well, I want you to write elastic potential energy. Okay. At C is being converted to kinetic energy as the man moves from C to D, causing the man to propel forward and upward as the elastic pole is being straightened. Yeah, because when it's bent, right, it will store a lot of elastic potential energy. So as it's straightened, right, the elastic potential energy is converted into kinetic energy. So this is application questions in sports science, athletic science, sports science. Yeah, I'm sure that some of you may have seen one of my YouTube video on this about the pole vault. If you can go to my YouTube channel, which I believe now has about 592 subscribers, and I need your help to increase the subscribership to even higher. Thank you very much, Inchi, and thank you for contributing the diagram earlier of the shadow that you have formed. So now I will pause the recording and allows some question and answers. Should they have any question and answers in this part recording. Okay, let's continue the next section. This is a very interesting question about a graph showing normal air, which is on the left, which has 21% oxygen, about 0.03 to 0.04% carbon dioxide. So normally nowadays, your school may teach you to put it at 0.04 due to the increased amount of carbon dioxide in the atmosphere. Okay, just for your information. And then this one is the composition is not normal. 92% oxygen and 8% carbon dioxide. Okay, this one quite likely they're doing an experiment on a person. That's mean the person is like breathing through an apparatus while the person is maybe doing light exercise. So they say compare the breathing rate. Okay, so you just mentioned this part. Okay, when a person breathes in normal air, his breathing rate remains constant, which is straight this way. When a person breathes in air with 92% oxygen and 8% carbon dioxide, his breathing rate increases. Okay, so basically it's you just explain what you see. Yeah. So what is this question about funny bunnies? Someone asked me this question. What is funny bunny? Okay, this part. So I screenshot this one and send to everybody here. Okay, next. Part B. When some people are trapped in a lift with no ventilation, their breathing rate increases, which is quite normal, right? If you get trapped somewhere, not only in a lift, maybe can be somewhere. It is believed that this happened because there is insufficient oxygen for the people trapped in the lift. Okay. So actually, you see in the normal atmospheric air, right, there's 21% oxygen and 0.03 or 0.04% carbon dioxide. So in this part B question, they are asking you using this information on this graph. Okay, that means you have to answer by using the information in here as well as here. Okay, these two graphs. Okay, explain why this belief is incorrect. So that means you must explain why that these people, the increased breathing rate, right, is due to insufficient oxygen. Okay, insufficient oxygen. So your answer must tell me why that this statement is incorrect. Perhaps not due to oxygen, maybe it's due to carbon dioxide. Okay, so actually the answer is the belief is incorrect, or this belief is incorrect, even though the amount of oxygen was 92%, which is on the right-hand side, the breathing rate still increased. This increase must be due to the high percentage of carbon dioxide in the air. Okay, interestingly, if you calculate mathematically, if you take 8 divided by 0.03, you will get about 267. Okay, so what I mean is if you go and calculate 8% or 8 divide by the 0.03, you will arrive at the answer like 266 point something something. Okay, so I round it about is about 270 approximately. Approximately this amount. Okay, that means although it's 8%, but it's actually 267 times more than the normal carbon dioxide. That's why it caused the breathing rate to increase. Okay, so this is the answer for this part B, which I will screenshot and send to you now. Okay, so you should say that this belief is incorrect, even though the amount of oxygen was 92%, the breathing rate still increases. This increase must be due to the high percentage of carbon dioxide in the air instead. Okay, next one is the interesting food web in a pond community. So some students, they are not familiar with the word tilapia. Tilapia is actually an edible fish in Singapore. And this great diving beetle is an insect that actually can stays underwater for a temporary amount of time because it carries a water bubble, can trap water bubble and breathes underwater. That's why it's a great diving beetle. So just like you go diving, right, it carries oxygen tank. Okay, so you see that it was observed that when the population of hydrilla is an aquatic plant, decreases. So I want you to annotate, you put the arrow down, decrease. The population of tadpole decrease as well. So population of tadpole drop. Okay. Apart from the level of oxygen in the pond decreasing because of the decrease in population of hydrilla, suggests another reason why the population of tadpole decrease. So because tadpole, they breathe through gills, right? So if a lesser hydrilla, due to the process of photosynthesis, there'll be lesser dissolved oxygen in the water, right? So they say beside this reason, okay, beside this reason, what is another reason that you can think of that support the decrease in the population of tadpole? Okay, so what can you think of? Okay, look at what are the predators. Who eats tadpole? There's only one, right? Tilapia, right? So because you know tilapia eats both the hydrilla and the tadpole. So if there's lesser hydrilla to eat, right, the tilapia will feed on more tadpoles. So that's the reason. Okay. So there's a reason for this part. So you put it down this way. It said it is likely to decrease, okay, as the population of tilapia has less food to eat because less hydrilla. Okay, wait first. Let me see how to improve the answer. Yeah. Okay, maybe you improve by saying S. Okay, I change this part. Population of hydrilla decrease. Population of hydrilla decrease so the tilapia. So tilapia has food, less food, which is the less hydrilla to feed on, and will therefore feed on more tadpoles. Okay, this part is the better one. Okay, you mentioned population of hydrilla decrease. So tilapia has less food, which is the hydrilla, to eat, and will therefore feed on more tadpoles. Okay, this part. Okay, next question. You need to analyze the whole food web. They ask you, from the food web, which population will be most affected if the frog did not lay eggs? So this is how you do. Okay, if the frog don't lay eggs, that means they don't have any tadpole, right? So you can cross out the tadpole. So you see what happened. If there's no tadpole, there's one animal has no food. Can you see the great diving beetle? Yeah, so the great diving beetle is most affected. So you just put the great diving beetle for this one. Will be most affected. Okay, because okay, here they didn't ask you for the reason. In case they ask you explain a reason, you just say that if the frog do not lay eggs, right, no tadpoles will be hatched. Therefore, the great diving beetle will not have any food. It will die of starvation. Okay. Okay, which population would benefit most from the rapid increase in tilapia? So answer is the kingfisher. Okay, because if you see here, right, kingfisher eats tilapia and it's a lot of protein because the animal quite big. Okay, so it's the kingfisher. Kingfisher. Okay, then I put this is additional question, right? Explain your answer to part C. Okay, why this one increase? Because the kingfisher have more food, and this would increase the rate of reproduction. Okay, more food will help the kingfisher to reproduce more. Okay, somebody sharing something. Join as a guest. Sichuan left. Yeah, but she haven't come in yet. Okay, I screenshot this and send to the chat group. Okay, let me see how much time we have. Okay, maybe I pause for a while to ask if there are any questions we clarified. Okay, let's continue this question here. It's about heat gain, heat loss. So you notice here, this experiment, there's a flame here, and this is a hollow plastic tube. Okay, hollow means air can move through freely. So I want to highlight this part. Okay, hollow tube. So that means the movement of air can flow freely left and right. Okay, so you can annotate this one. Okay, so it says that at the beginning, the temperature of both was the same. So you highlight this part, 30 degrees. And after 15 minutes, right, you will see the temperature changes differently from both sides. So as the time proceeds, right, you will see the one at point A increased by 20 degrees. Okay, 30 to this one, but the other one only increased by 2. So one is 20, one is 2. It's 10 times more. So what does this experiment shows about the property of air? So as you know, right, air is a poor conductor of heat. So this will give you the full marks. Just mention air is a poor conductor of heat, or you can say air does not conduct heat well. Okay. Air is a poor conductor of heat. Okay, next is the application question. Okay, application question. So I actually annotated here, external in Singapore is about 32, but recently the temperature soared to like 38 in certain afternoons. The interior, usually we set our air conditioning to about 24, 23. And then there's this layer of air trap in between. So this question asks you, based on your answer in part A, this part, right? That means your answer for part B, you must have this word there, or this phrase, air is a poor conductor of heat. Okay? So you have to explain this part. Okay. Which I believe I have put the answer here. Yeah. So you should say that the layer of air between the glass is a poor conductor of heat and reduces heat gain from the outside of the air-conditioned offices to the interior of the offices. Okay, because they mentioned about this scenario in the air-conditioned offices. Okay, this actually helps to save energy. Yeah. Okay, but this window will cost more. But over the time, if they build the building, usually a building lasts more than 10 years in Singapore. So it's worth spending more money to conserve energy. Okay, why they conserve energy? Sometimes they may ask you, how does this type of window, the double glazed window, helps to conserve energy over a long period of time? Okay, because the external temperature is high, with this double glazed window, right, the interior of the office will gain heat slower. So you do not need to set the temperature of the aircon too low. Because the lower the temperature, the aircon use more energy. So this one actually will reduce the heat gain. So this one additional thing you can know, talk about energy saving. So part C, maybe I say, describe how this window, or explain how this window helps in energy conservation. Okay, so it's about heat loss and heat gain. Okay, now I pause for a while. Just now, somebody want to ask question. Okay, next question. I want to highlight this part because many students, they did not highlight this part, then they can't answer. Because they are two different beakers. Okay, meaning that they are of different materials. Okay, they contain pure water at room temperature. So this one I annotate here, I put 500. And then on the right hand side, I put 300. So logically, if there's lesser water and with the same heat, right, beaker B should boil or should reach 80 degrees first, right? But they say after 10 minutes, both reach 80 degrees. So they ask you suggest. Suggest means there can be more than one possible answer. Suggest why. Okay. So the reason is because beaker A will have more water like this. Is made of the material beaker A is made of a better conductor of heat than material B. Okay, that's the reason. So I say material of beaker A is made of a better conductor of heat than the material of beaker B. Okay, this part. Better conductor. Okay, next part B is related to part A. Because can you see the word then? So I want you to highlight this word. Although it's a small little word here. Then. So that means from the above, PB remove 10 or remove 100 ml of water from A. So initially it was 500, right? So now become 400. Okay, I want you to highlight this one. So the new volume is shown. That's mean nothing to do with B. B retained 300. So now with lesser water, right? With the same amount of heat, therefore, beaker A would start to boil first. Correct? Yeah. So I say explain your answer. Since there is lesser amount of water in beaker A, therefore the water would take a shorter time to boil with the same amount of heat. So you must mention this, same amount of heat. Okay, would take a shorter time to boil with the same amount of heat. So I will screenshot this and send to you all. Okay, you put temperature of water in A higher than temperature at the start of experiment. Let me see. Oh, also can. Yeah, because there's another possible answer. Some of you put the temperature of, okay, another possible answer by Dora is temperature of water in A, right? The starting temperature, yeah, is higher than B. Can, acceptable, can. Okay, so for the part A got another possible answer. You can say the temperature of beaker A, or water beaker A is higher than the temperature of beaker B in the beginning. Okay. Next one, part B is this one. Okay, part B is this one. Okay, but questions say that the water, oh, let me check. Thank you. Somebody highlighted to me. Oh, actually, Dora, actually, I think yours can know because there's one condition here. They say containing pure water at room temperature. Containing pure water, that means both have the same temperature. Oh, so you take note of this. So cannot yours. Thanks for highlighting to me this student, Lucas, for highlighting this because they're room temperature. So both at the same temperature. So there's only one possible answer. It's okay. Never mind. Thanks for highlighting, Lucas. So what I do now is I screen shared already. So you just give me a second to put it back here. So today, let me check. Screen view, gallery view, we're all here. Okay, now we take a short break. We come back in about 10 minutes time. Okay. See you all later.